Hi guys, this is Fazan and welcome to this session from Great Learnings. So before we start, am I audible guys? Just quickly. And please guys, just come up with a Great Learning Academy initiative wherein there are 80 plus courses are available for limited amount of time. Link will be shared in the description. Please go guys and check those links out, okay? Show you quickly. So this is the thing I'm going to show you. This is the most important thing actually to run your program, okay? So you go into C drive, okay? Then you go into program files, okay? Then once you have downloaded Java and installed it, you will get a folder here, okay? You will check if these two things are present. I will tell you exactly what two things are, but right now you need to just understand that there should be a JDK, okay, Java Development Toolkit, and JRE, Java Runtime Environment, okay, which is used for. I will tell you what it's used for. For now, just remember that these two things should be there, okay. Once they are there, then you just open your control panel, okay. I will search it here, control panel, okay. We are setting up the environment variables here, okay. Then go into the system, okay. Then you go into the advanced setting, okay. Then environment variables, okay. Now if there will be a variable which is named path, okay. Edit it, and what should you write here? You see the first line that I have written here, program files Java JDK hyphen 14, because I'm using version 14 of Java, okay. And bin, you just need to copy the address from here, right? In second I will show you where did you get this address. Okay, here it is, okay. So just cancel it, and now let me show you. So okay, cancel this as well, and here it is, okay. So you just need to go into JDK 14, go into bin, and then this address here, just copy it, okay. Control C, copy it, okay. Then open your control panel, okay. Open your control panel, okay. Environment variables, then the path, use edit option here. If it is not present, create it, okay. In most of the systems it will be available, okay. Now just print here, okay. Just double click anywhere, maybe it will be different in your. You can hear me guys? Okay, let me check. Okay, cool guys. So now where were we? Yeah, okay, sorry for the interruption. Okay, now once these variables are set, these will be responsible for running our code, compiling our code. These two variables are very important, and once they are set, you don't have to ever worry about them, okay. This is the first step that you want to do, okay. Now we are done with this, with the environment variables. Close all these files, and now we will start our thing again, okay. So after setting up our environment variables, open command prompt from the folder or the drive where you are, okay. For example, let me show you. I will open this file that has been written here, okay. Now where is it? Just give me a second. I will go into the home. I will check for that file. Okay, it's not here, it's here, okay. This is my first file that has been written, right? Public class my first code, public static void main hello world, okay. Now what will I do? I will just go into this section here, right? I will write here cmd, okay. A command prompt will open, and now Java file is downloaded and saved into program files, which is in C drive, but with the help of path variable set, I can run it from here as well. So whatever I do will be for Java C for compiling, and then I will write the name of my file, my first code dot java, right? This is for compiling our code. Done. No error, compiled successfully. Then I will run it. For running the code, I will just write java. Because of JRE, this is able to run this. Okay, so our code, first code, has been run and it has given the output of hello world successfully. Okay, now whatever we do, we are not going to use this approach in this session, because we will not waste our time for compiling and then running our code. Rather, I will use an IDE on Geeks for Geeks. We will use that thing wherein we can get easily and quickly we can compile our code and run our code. Done. But if you want to do it on your system, I have shown you the way. You can use that way. Okay, cool. Now we will start again and go ahead. Okay, just a minute. Yeah, so what we wrote for compiling our code, java c my first code dot java. Why this is written in this format, this will be also clarified in this session. Okay, then what we did java for running our first program, that is my first code. Okay guys, till now we don't have any confusion, right? We have cleared all the things. Now we will go into the business end. So what are the features, why we should learn java? Because it's simple. If you have any familiarity with language like C or C++, there is much similarity with those C and C++ have similarities with Java. Even if you don't know, that's okay. Things will be covered in this session. That's why we are here, and we are here to learn this session from basics. Okay, cool. So it's simple. Object oriented, right? We will cover all the 4 pillars, that is on which object oriented stands, that is inheritance, polymorphism, abstraction, and encapsulation. These things will be covered. Okay, platform independent. We have a thing called virtual machine, JVM, which converts our code into bytecode, which can run in a Java supported platform. That means if you have a program, you have compiled it, and now you want to run it on another system, if Java is installed in that, you can easily run it. So that's what we mean by platform independent. You don't have to just do the things in other programming languages which are not platform independent. So there's a thing that you need to change your code because it's not supported, operating system is dependent on it, all those things. It is platform independent. If you and your friend are doing your code, so once he shared the file, you can easily run it if it's a Java supported platform, right? If Java is installed in it, it is secure because it has a box called JDK, which is responsible for handling the execution. Okay, it does not support pointers, because using pointers we are directly changing the addresses. Those can be there can be fatal errors if we try to change some address which we are not supposed to. That can be fatal, right? You can get an error, your system might crash, all those things, right? It does not support pointers. Multiple inheritance, right? There is a thing called diamond problem, right? I don't know if you guys have heard about it. I will give you just a brief what a diamond problem is. Basically, one class is inheriting from 2 other classes, or what you I can't say inheritance right now. So let's suppose you know what inheritance is. Means that you are just using whatever is in the parent class, you are using it in the child class. Okay, now it has a variable, and both these classes have the same variable. Now these classes are inherited by some other class, both these. Now there is an ambiguity because he's also having that same variable and this class is also having that same variable, right? So there's an ambiguity, what value should it use, or this can lead to a system crash, right? So this is secured because multiple inheritance is not here in Java. It's efficient because it uses just-in-time compiler, which is basically nothing but the best in compiler and the best in interpreter. The best in both of these worlds has been used in JIT, that is just-in-time compiler. Okay, efficient, right? Multi-threaded. Java supports multi-threaded because it allows to keep us multitasked or to execute concurrently without occupying such much memory. Okay, what do you mean by multi-threading? Basically, if you might have, I will give a naive example, right? So if you have used notepad++ or anything, any editor, right? You see, if you write something wrong, there comes a check that please, this is not grammatically correct, this is written in wrong, this is not written, the spelling is not correct, right? What is going on? You are writing and inbuilt internally there is a thing happening over it, right? That is multi-threading, a naive example. Okay, multi-threading. Java supports multi-threading. Okay, now let's talk about this thing, right? I use JVM, I use JRE many times, right? So now let's talk about what these things are Exactly. So first, let's see this picture. Keep it in mind. You're going to visualize it. What happens? You see, there's a JDK, a bigger box, right? Then there's a smaller box inside JDK, that is JRE. And then in JRE, there's JVM and some libraries and development tools. That is those binary files, those executable files which you use. That is Java C and Java. The commands which we use for running our program and compiling our program, right? So this is the thing, right? Now let's see what happens exactly inside. Okay, now we have a JVM. This JVM doesn't exist exactly, right? This doesn't exist. There is no such thing as JVM, but it's an abstract, right? What do you mean by abstract? Which is not present, which is just a virtual thing, right? This is a virtual machine that holds all our execution. This is responsible for our executions. Okay, this doesn't exist in reality. It also manages our heap memory and stack memory, garbage collector. There's a thing called garbage collector in Java. That means you don't have to worry about, for example, if you use this variable or if you use this memory allocation, you have used this much of space. You don't have to worry about freeing that memory. Like in we used in C++ or C, we used to free those things, right? In Java, there is a garbage collector who does that for us. Okay, you see how easy it is for us to write our code and then don't worry about the space that we are using. That's because of garbage collector. Okay, so JVM is responsible for these things. Okay, now what is JRE? JRE means Java Runtime Environment. It provides us the environment for running our pre-compiled Java programs. Okay, it contains all files and libraries to facilitate running the Java code. Okay, this is the guy that is responsible for running our code. Okay, you see now this image again. This JVM is nothing, right? It's an abstract for running our all for executing our programs, right? Java JRE provides a runtime environment. Now let's talk about what JDK does. JDK is nothing but a software that helps us to develop Java applications. It basically comprises of JRE and Java and the development tools. What are the development tools? Basically those Java, Java C, the executable files, that right? The binaries are Java C, Java, and all those files, right? Java was as we saw, as we have seen earlier, that Java was a file and Java was the command which we used to run our program, and Java C was the command which we used to compile our program. So this is all about JDK, JRE and JVM. Okay, now let's go ahead and now let's talk about the most important thing. Now we are into the programming end of this topic. Okay, now variables. You see, if you want to store anything in your day-to-day life, if you want to store water in anything, what do you use? You use a bottle, right? If you want to store maybe some rice or anything like that, you use a container. Similarly, if you want to store anything or any value inside this Java, you need to have variables, and the syntax of that is data type. That means which type of variable, which type of value you are using. For example, if you are trying to store integers, right? If you're trying to store decimal numbers, right, float numbers, you need to have that kind of a variable. So if you're trying to store an integer value, you need to write int, then a variable name, so that you can use that variable name. Let's suppose you use int x, then the value 5, let's suppose. Okay, the variables are this thing. Now let's see a little bit of demo how we can write our variables. Okay, so basically the above part is clear, right? Public class, why the class name we have here. Okay, so rather than doing this, why won't we do a small demo on it? Okay, quickly, since we have a lot much to cover, so I will quickly go ahead and write this thing. Okay, you see, this is the Geeks for Geeks ID I was talking about. We are going to use it. Simply we just have to write here, we just have to select this Java, right? We are using Java programming language. So then click on run, the output will be here. Okay, done, that's it. So now how will we create a variable? So we will write int, then x, right? We will just write 5. So what I am doing here, this is one type of one way with which we can define our variables, right? I am defining it and initializing it and declaring it in the same line. Then simply what I do here, I will just print it out. Okay, that is x, then run it, done, we are done, that's it. We will get the output as 5. You see how easy is this variable, right? Is this id that we are using here. Just give it some time. Okay, yeah, there is output 5. Okay, cool. this is taking a little bit time. You don't have to worry about all those things, Java, C and Java to run our programs. Okay, done. Then the other way. Now what I did, I write here y and I don't initialize it. Okay, let me remove this x. Okay, wrote y. This has been declared, right? Now I am going to initialize it in the other line. Okay, now write 0 and just print it here. Okay, similarly you get the output as 0, right? So this is how we define our variables. Okay, and declare our variables. So these are the two things that I just shown you. Similarly, you can have a string, right? Int roll number was declared and initialized in the same line. Then string first name Adam, right? It was declared and initialized in the same line. Then the other declaration that I just showed you, right, which contained just the declaration, and later we initialized it. Then for SOP, I will just refer system.out.println to SOP, right? It's easier for me to say, right? So SOP, then we print all those values. Okay, done, right? Now the naming convention. Most of us, when we try to write our variable names, we need to follow these particular steps. Okay, we need to have this clear naming convention, right? So variable name should begin with a letter or a dollar sign or an underscore. Okay, what do you mean by underscore? There's a small dash which will be present, right? You can start, right, this name here, the valid example, this small dash, this is called an underscore, this is the alphabet, and this is the dollar sign, right? This is a valid variables with which we can define our variables. That means the naming of our variables. You can't write integer number or the numeric digits, that 1 2 3 apple. This is a wrong way to define a variable. You will get an error. Okay, so the first character can then be followed by any combination of letters and digits, right? The first letter should be among these things, right? The first thing, right? It can be a letter, dollar, or an underscore sign. Then you can follow anything, right? You can write dollar 1 2 3, that will work. Okay, but that doesn't make any sense. The naming convention is this. You can write, but you have to keep this thing in mind that you don't you always, when you define a variable, keep it related to your program. Okay, for example, if you're using something to count, rather than keeping its name as x, you should keep it as count, right? So that you get a clear idea that this thing counts. Okay, so moving ahead, a variable cannot have the same cannot be same as keyword, as they are reserved for special purposes, right? So variable name cannot be same as keyword, right? Variables are case sensitive, right? If you define something in smaller letter, you can't access it using capital letters, right? Lowercase, for example, you use this apple, right? It's all in lowercase. Now you are trying to access apple as in uppercase, all the letters are in uppercase. That won't work, right? So you have to keep this thing in mind. Now the types of variables, I'm going to cover this thing. There is a lot to cover, so I'm going to quickly ahead something. If I'm not showing it's like in demo, if I'm not programming, you don't have to worry. Those things are important, and you just need to have a clear idea of those things as well. Okay, so now the types of variables. So there is the thing called instance variable, which I cover later. Okay, for now you just need to know that anything, for example, if I'm creating any class which contains methods and functions, right? So if I'm trying to access those methods and data members, right, I need to have an object. So the object is an instance variable of that class. So basically an object is an instance of a class. So similarly, it's called as an instance variable, right? It gets copy of those all variables, right? All the methods and functions which are defined in that class, this variable gets that. Okay, that's called instance variable, right? Then we have the static thing, right? Which we saw earlier, public static void main, right? Whenever we are defining anything in a class, we need object to access it. But if it's a static, it doesn't need to have an object. It is directly called from the class name. Okay, that's what we mean by, also known as class variables. Variables declared as static maintains a single copy in memory and is shared by all the objects of the class. Okay, so this is the thing. The static variable doesn't belong to an object, it belongs to a class, right? You got that idea now why we are not creating object for that main method to call, right? Because it's static, we can directly access it with the help of class name. Okay, It can be directly using by class name, right? What we did in the main method, right? It's if non-static methods are there, you can't access or manipulate static variables with the help of non-static methods. Okay, right? So if it's static, you have to be static. If it's non-static, then you can access it with the help of static, but vice versa is not true. Okay, now then we have local variables. Local variables are anything which is defined in a block. For example, if you wrote if x is greater than y, then you in that, now we found that it is true, then in that block we will define int I is equal to 0, and then we print that I. Okay, so if now we are not in that block, now we are outside that block, now we are trying to access that I, we can't do that because the scope of that variable is in local environment, right? It is within that block. Okay, cool. So these are the types of variables. Now let's see. So basically, why now earlier what I said was that instance variable is something that is associated with a class and we use object to call that. Now whatever I have written here, that int I is equal to 100, and I have written instance variable. So was I wrong? Was I wrong when I said that instance is? No. Basically everything in Java is in the form of objects, right? So if you want to access anything, it is basically a primitive data type here, right? We will cover data types, right? No, right now you just need to understand that int is a primitive data type. Whatever is written in this int is internally converted into a wrapper class called integer, in which everything is caps, right? integer, integer class. So that's why I have written this as an instance variable. So we don't see it's an instance variable, but internally it's executed in that manner. Okay, just don't have to worry anything about. JVM will cover this thing for us. Okay, JVM, JDK, all those things are here to help us. Okay, it's much simpler. Okay, now static, it's a static variable, right? We just saw this example in the main method as well. Then we have this k, it's easy, the local variable. Okay, cool. Now let's move ahead and now quickly go ahead and we check out operators. So what are operators? Basically we have operators like unary operator, arithmetic operators, shift, relational, bitwise, logical, and assignment. So what are unary operators? Basically unary means you don't need two operands, right? You just need a single operand. Like I will quickly show you what do you mean by this thing. Okay, I will go into my geeks for geeks. 1 second. Yeah, quick. Let's see. So unary operators, now y has been defined, right? So this is y, right? Now what I will do, I will write y plus plus here. So what is this? What do you mean by this line? Basically this means nothing but y equal to y plus 1. This is it. That's it. Now how we write comments in Java? Basically double slash or the slash that is written in one that is multi-line comment. How we write this thing? This is basically this thing, and then here it is. This is how we write multiple line comments, and single line comments are written in this fashion. Okay, okay, cool. So this is gone, right? So now you understood that internally what is happening when we write I plus plus. Okay, cool. Now, yeah. So what we wrote is a post increment. Basically, it is assigned first, then the value is incremented. Post increment. First assign, then increment. So if I use I plus plus here, okay. So if I use I plus plus here, then what I should write here, okay. Just a minute. Okay. Just give me a minute, guys. Just hold on. I think you're not getting my voice. Okay. Just a minute. Okay. Am I now? Is my voice clear? Is my voice clear, guys? Just write a yes quickly. We are running out of time. Yeah, cool. So yeah, this is the post increment. First, what will happen if I, now we have incremented this value, right? So what we have written, I y plus plus. So first it will be, okay, just a minute. Yeah, so first it will be assigned, okay, the 0 will be assigned, then it will be incremented in the next line. So if you see, if you observe, what should be the output here, and then if I print this statement again, see the beauty of this post and pre increment right here. So now if I write here this thing, and then again I will print this. Now this time I will use pre-increment. Similarly, you can use decrement operator, pre and post. Now what happens? 0. First we have value 0. So what will be the output here? Again 0, because I said first assign, then increment in the next line. Okay. Now what will be the value here? It will be 1. Obviously in the next line the value will be incremented, right? Now what happens here? It is increment first, then assign. So the value should be 2 here. Okay. Now quickly go ahead and run this program. Okay. This is all about unary operators. Okay. Similarly, you can use decrement operator, right? Pre and post. Similarly, same thing happens there. If you're using pre, then assign, increment first, then assign. Okay. And post, assign first, then increment. Okay. Now you see 0 1 2. That's what we expected, right? 0 1 2. Cool. Let's go move ahead. Let's move quickly. Okay, so this is the thing, unary operator. Then we have arithmetic operators. You all know those things, right? Addition, subtraction, division, multiplication, and modulus operator. Modulus basically you might not be knowing. So basically what modulus does, it gives you the remainder. For example, if you are trying to divide, if you are using mod operator, right, 6 mod 6, what should be the value? In case of division, it will be 1, right? But in case of modulus, the result will be 0, because 6 divided by 6 will be, the remainder will be 0, right? Similarly, now we have shift operators, left shift and right shift. I have put a slide because many of you us will not be knowing this as a beginner, right? So there are two kind of shift operators. First is left shift, the other is right shift. Okay, the left shift, basically what it does, it moves the bits. Basically it will work on bits, right? So it moves the bits in the left direction for the specified value. For example, what is written in this program, if you can check, so a b is initialized with 8, right? Then we use left shift. So what left shift does, it will shift bits to the left side. So basically we all know that when we try to convert integer number into a binary, so there's the thing we call 2 raised power 0, 2 raised power 1, 2 raised power 2, right? So what will be the value of this 8? So it will be 0 0 0, the LSB is 0 and the MSB here is 1, right? If I'm talking about only the 4 bits that I'm using, 0, that is 1 2 4 8, only the 8 bits that 4 bits that I'm using. So now it shifts its two position to its left. So what happens at 8th position, the 8 value position, it will be 0, and 16 it will be 0, and on 32 it will be 1. So that's why when we use left shift operator, right, the number gets multiplied. Okay, so the number gets multiplied by how much? It will get multiplied by 2 raised power n, where n is the number of shifts, that is 2 here. That is 2 raised power 2 will be 4. Now 4 multiplied by 8 is equal to 32. That's why the value in the output shown on the screen is 32, because it got multiplied 2 raised power n times. That is 2 raised power 2 times, that is 4. Okay, so 8 into 4, that is 32. Okay, similarly when we do right shift, a number gets shifted to right position, so a number will be decreased. Okay, so by how much? Similarly 2 raised power n times. Okay, so that is similarly here 4 value. Now we will get 8 divided by 4, that is 2. So that's why a number b got decreased to 2. So these are the two operators, right? Shift operators, left shift and right shift. Okay, now the relational operator, we all know these things, right? Greater than sign, less than or equal to. So I'm covering everything up to this point so that you have a clear understanding and you are just ready, and you're ready to get your hands dirty in Java. Okay, so everything, the basis will be covered here. Then you go on the IDE, some IDEs, Geeks for Geeks, and you can also join some courses as well, right? So this is the thing, this is the main objective of this course or this session, right? Cool. So now the relational operators. Okay, now it's gone, it's very easy, there's nothing new to these relational operators. Then we have bitwise. These operators works on bits. So if I say, I have also given a slide for this. Okay, now relational operators, there are two new operators, that is double equal to and not equal to and equal to. That's for equality check in relational operators. Okay, now bitwise operators, it computes by going bit by bit. Okay, it's very important that you guys understand this bitwise operator. Okay, it goes bit by bit, both side is checked irrespective of what the first expression computes to. For example, let's suppose you don't have to worry about what I said. Okay, let's suppose you have two numbers 8 and 2. So 8 will be converted into binary. What will be the binary of 8? 1 triple zero, right? And what will be 2? 1 0, right? The last two bits. So now we will do AND on it. So basically AND will give result 1 only if both the bits are 1, right? So 0, the first will be 0 0, then it gives 0, then 0 1, it will be again, what will be 1 0, then 0 0 0. So now if you do an AND operation, you just get some page or something, you can just visualize this thing, that when you do an AND of 8 and 2, you will get your result as 0, because none of the bits are there whose corresponding bits are 1. Okay, cool. Now in case of OR operator, you will get 1 0 1 0, that is you will get 1 2 4 8, you will get 10. Okay, just write it somewhere, go ahead and practice it after this session. Okay, now the XOR, this is the most important, and this is a very important in terms of competitive programming, this operator, the XOR operator, XOR, which is called also. Okay, so which returns 1 if both bits are different. Okay, else it returns 0. So if we have 1 0 or 0 1, it will give us 1. If we have 0 0 or 1 1, it will give 0. Okay, similarly, if we do an XOR operator on number 8 and number 2, what will be the output? So the output will be again 1 0 1 0, that is 10. Okay, then the NOT, it's completely that whatever it gets, it just changes it to 0. If it gets 1, change it to 0 0, change it to 1. Okay, cool. Bitwise operators gone. Logical basically is used when we use conditions like if statements. In that if statements, if both the conditions are true, only then do this. So we will use AND operator, because AND checks if the value, if the condition in the left side and the right side of the AND are true, only then AND will work. In OR, if any one of those are true, then it will be true. Not will just negate your answer. If you are expecting true, it will just convert it to false. Okay, then the assignment operator, which we have used, right? X is equivalent to 5. What is that? That's an assignment operator. Then ternary operator is similar to if else statement. Okay, so basically whatever is written before the question mark is the condition, and then whatever is written in the first this part of the semicolon, right, of these two dot signs, whatever it is written in the first part is the expression that is executed. If that expression, if the condition is true, and if it's not true, that will be executed. Okay, the next part. Cool. So this is the ternary operator. Shift is gone. Right now we come into the data types. There are 8 types of data types, that is primitive data types. What are they? Byte. So byte is it contains a size of 1 byte, right? As the name specifies, it holds by default the value is 0. So int is of 4 bytes, by default size is 0. Short 2, long 8, default size is 0. Char 2 bytes, boolean 1 bit, either true or false. Float 4 bytes, double 8 bytes. You see, int, short, long, all these come in a single category. Float and double, this come in a single category. Okay, so there are primitive 8 types of data types. Okay, 8 type of primitive data types. Okay, only these things are there. So also these are converted into objects. Okay, you don't have to worry about that thing. That is done for us by JVM. Okay, so basically what happens, these primitive data types, because you see I told you earlier that Java is an object oriented, everything is in the form of objects, right? So to do this thing, right, we are not using any objects here, right, in these primitive data types, right? But internally what happens, these are converted into objects, right? The wrapper class is there, with the help of which we convert these into objects. Okay, that's why I wrote there the instance variable. Okay, cool. Now let's move ahead, and the conditionals, these are very simple. You write if, right? I'll quickly show you, we are running out of time. I'll quickly show you. Okay, so this is nothing but if, right? Let's say if y is greater than 0, right, the relational operator that we are using here, then is y greater than 0? No. So this line should never be executed, right? So y plus plus 1 plus plus, right? Else, the else part, else, sorry, my bad. So else do this. Now let's not make this thing because there will be no change in the value. We want the value to be changed, right? I will write this thing. So if y is greater than 0, now what should be the value? Herein we have 2, right? Now what should be the value? 3. The last output should be 3, right? If this line would have been executed, that is if y is greater than 0, but it is not, so that won't work. So it is giving us 3. Okay, just a minute. Okay, what happened is y greater than 0. Okay. Just a minute. Yeah, let's see. Let's run this program. Just give it some time. Yeah, cool. We have 1, right? If this would have been executed, then our output should have been okay. There's a question. Just give me a minute. I will cover it here. Where to be used this operator? Okay, so where we can use it in here, like in if y is equal to 0, then what happens? We are checking the equality condition, right? If y is equal to 0, then execute this step, right? So if we run this thing, then the first thing will be executed, right? And our output should be 0, right? Okay. Just give it some time. Is my internet working? Yes. Okay, cool. We got this, right? So is 0, right? So we checked here. Equality condition is used here, right? This double equal to sign. So y is equal to 0, then system.out.println print. So this is the post increment, right? So the increment will be done after, right? So if I'm going to print everything, sorry for the disturbance, and what will be the output, right? So it will be 6, right? So for these many times, that is 1 2 3 4 5, 5 is less than 6, right? It will execute, then it will become 6, then 6 is not less than 6, right? Then the output will be 6. Okay, you see, while loop. Now you see, we declared a variable here and incremented it here and checked the condition here. Would it have been kind of a efficient way if we have written it everything in a single line? Yes, there is a way. What is that for? Let's suppose we haven't defined this thing. Now let's remove all these things. We don't require them anymore. Now what do we do here? We will write int y equal to 0, right? The initialization, right? Then if y is less than 6, write the condition, and then y plus plus, that is the updation. Until then, do whatever you want. Just print the value of y. Okay, so how many times will be y printed? 6 times, right? 0 to 5, that is 0 1 2 3 4 5. Okay, just a minute. What happened here? Okay, what I did, I initialized y and used I. Okay, my bad. Okay, cool. Yeah, and I'm again printing y. Yes, this should be it. Okay, it will again give an error, I know. Yeah, I will run it again. Now everything is done, right? Y has been removed. Yeah, cool. So what will be the output? 0 1 2 3 5. So this is the for loop. So this is the efficient way to write our looping conditions, right? So this is done. Now the classes. So what is a class? Class is basically an blueprint, right? A blueprint of real life entity, right? So what do you mean by that thing? In a class, we use our first programming pillar, that is of oops. We use that. What do you mean by that? So basically everything written in Java is in class. So it consists of data, that is variables, or also known as data members, and methods, basically functions. Anything which is inside a class, any function which is inside a class is called a method. Okay, basically it's implementation of encapsulation, which is one of the one of the oops pillars. Okay, keyword used is class, as we have seen. As per the naming convention, it follows that why I use that. If you have observed, my was M was capital first, F was capital, and then code C was capital. Why I use that pattern? Basically it is used by the Java, right? So it's a naming convention, and it's, if you don't write that thing, it will work. But so if you somehow shared your code in your company or anything like that, so you better follow some naming convention which the Java follows, so that it's easier for others to understand that okay, this is a class, right? So all the code must be inside the class in a single document and can have multiple classes as well, but only one public class. Okay, cool. This is all about classes. So how we write a class? So class basically contain, this is a container class, and in this we have 3 data members and 3 functions or methods, right? Also called as methods. Okay, so these functions, these methods are weight, set color, set price, and then we print all those things, right? Is it clear? There's nothing new to it, right? Just the class keyword and the container name of the class, and then the data members, weight, color, and price, and that's it, right? Cool. So this is how now we have created a class. Now how we are going to use or access these things which are in the class? With the help of object, right? The physical entity of the class. Class is nothing but an instance of a object, is nothing but an instance of a class, right? Its class is instance. That's what we also known as instance variable. New keyword is used to allocate memory, right? Here in we have written new, right? The first thing that is written in this example, the container, it's name of the class, then the object name is C1, then new to allocate memory, and this container, what is this? This is a constructor. Now what are constructors? We will cover that. A constructor is nothing but a special method that is used to allocate memory and initialize the objects. Let's see first the demo. Okay. So basically this thing, this line that is written here, I will just show you, then the things will be clearer. Okay, I will quickly go ahead and show you this thing. Okay, so basically if I have to create a constructor of this same class, I will just write GFG. It is same as the class name. Okay, then we have this thing here. Okay, then whatever we write here will be printed. Okay, so for example, if I write this thing, right, I will cut this thing and paste it here. Okay, this is extra. Now I will write here constructor. Okay, constructor, let's write it exactly what it does. Okay, cool. So now let's remove this line. Now you see, whenever I create an object of this class GFG, with the help of O is the object name, and new keyword is to allocate memory, and GFG, right, the class name, and this is the constructor calling here. Okay, now you might be thinking, we didn't created any object there, right? Earlier we didn't created any object. Was this constructor called? Yes, it was called. By default, a constructor is made, default constructor, even if we are not using this constructor. I will show you the example as well. This is the constructor, this will be called, so our output should be constructor, right? Okay, right, it's the output constructor. Cool. So now what if we didn't write this thing? Will it work? Yes, it will, because by default a compiler will create this thing. Compiler will create it for us, a default constructor, so you don't have to worry about that as well. But if you want to do anything in a constructor, right, it won't give any output because we are not printing anything, right? We are not doing anything, we are just creating an object, right? Cool. So this is how constructor works. Okay, constructor is a special method, right? It is used to allocate memory and initialize objects. It does not have any return type, and its name is same as the class name. Compiler implicitly provides a default constructor to allocate memory. If no constructor is explicitly defined, then it will be defined for us. Okay, constructor having parameters, so you can pass parameters, right? Also that constructor is called parameterized constructor. Okay, when new is encountered, it calls for a constructor, right? We saw that whenever we wrote new, and that thing, the name of the class and the parenthesis called the constructor. Parameters passed at the time of creation of the object determines the constructor should be called. Okay, Cool. Now super and this keyword. These two keywords are very important. Super is generally referred to. You see, now what we did here, it was all about encapsulation, right? Now we will see inheritance, which is also the next pillar, or which is one of the pillars. There are four pillars actually. Encapsulation that is done, right, with the help of classes. Now inheritance, we will see inheritance. First, we will see these two words. Basically, these two keywords, super is generally associated with a parent class. We will check what a parent class is, what a child class is. Whenever we use extend keyword during inheritance, a parent and child relationship is maintained, right? You can call parents methods, data members, and constructors using super. We will check those things out, okay? And also, while calling parent constructor, we can use this thing, okay? The super keyword. Now, this is all about what we do in the parent, how we can call methods, data members, constructors, all those things, how we can call of a parent class. What about the child class? How you can use something that is actually within that class, within the class you are working. For that, we have this, okay? This is associated with the current class, okay? It can be used with what? Methods, data members, constructors, okay? And all those things. While calling the current class constructor using this, it should be one line on the first line of the code, okay? Similarly, that thing, the super should also be the first line of the code, okay? Cool. Now what is inheritance? We will use this thing, don't worry, I haven't skipped these things. We will use these things in inheritance, okay? We are running out of time, so I'm just going to quickly cover all these things which I have planned, so that you can just quickly go ahead and do your start practicing in Java, okay? So the inheritance, one of the most important pillars of OOPS, right? It facilitates code reusability because we are inheriting something which is already present in our parent class and then we are using it, okay? Child can also implement data members, right, on methods on its own. So similarly, if you something he can inherits, it can also create something of its own, okay? It is having is a relationship, okay? There's a is a relationship. Java does not support multiple inheritance due to its ambiguity. We have already covered that, but we can implement multiple inheritance through interfaces, okay? Cool. Now there is a thing called method overloading and method overriding, okay? So what do you mean by method overloading? Basically, we are creating methods with same name, okay? For example, you are creating a method or a function. Let me keep it simple for you guys. We are creating a function named add. So add can have 2 arguments, add can have 3 arguments, same name, add can have 4 arguments. So all these methods with same name but different arguments is known as method overloading. You can do it within a class, okay? So basically it is used to provide the programmers the ease and understanding the code, right? Just by changing the return type will not be as effective, or you can't do a method overloading with the help of that. So you say I'm using add, it will have an argument of 1 integer. I will use again an add method, it will have again an argument of integer, and just I will change the return type. One will be double and one will be int, so that won't be in method overloading. That will give you an error, okay? Now what is method overriding? So basically method overriding is a compile time. Everything that happens during method overloading happens during compilation. Basically it is a polymorphism. What do you mean by the third pillar, the polymorphism? To act differently on different inputs. Basically how you can say that, all right? Polymorphism, how? So basically when you used a function with 2 arguments, then you used a function with 3 arguments, same name, right? But the arguments are different, right? So you see, based on our input, our output changes. Same function is called, but based on the input, output change. So polymorphism, many states, right? Now similarly, runtime polymorphism, how it happens? Basically when you are inheriting something from the parent class, you will write the same method. For example, in parent class we have method add, and in child class you will also have the method add. Basically you are overriding. This type of polymorphism is called runtime polymorphism, okay? So this is the third pillar, right? Now let me show you first how to use this thing, then we will go ahead. Okay, now quickly let's create a class, right? What is this class? Okay, class ABC. I will use the proper naming convention. ABC is the class, okay? Done. And now we will just use some variables here. Int I. Let's make a constructor. Okay, this is written abstract. Just a minute. ABS. Cool. So I will use a constructor here. ABS, same name. So it should be capital. Let me keep it capital so that we are following a proper naming convention. Okay. ABS. ABS. This is a constructor. We are doing nothing but printing what? Printing anything. Println, right? Println hello. Okay, cool. Hello. This is a constructor does this thing. Now what we do here, we will do nothing. We'll just we'll just use extends keyword here to use the abs. Okay, so basically we are using inheritance here. Okay, cool. Now what we will do in gfg, this second class, what we will use, we will use a constructor to initialize our object, right? What object? We will define it here, int let's say int role. Okay, role equal to nothing. So now what I will do, will just pass an argument here, and I will also write this thing as role. Okay, now what I will do here, I will just use this dot role. Why this? I will tell you exactly why. Okay, so this thing is done. Now here what I will do, I will just call the upper constructor. This constructor will be called of the parent class, right, with the help of super. Okay, now herein what I will do, I will pass 10. Okay, now finally what I will do, with the help of this object, I will access this role, right? I can, right, this role I will access, and I will use println to print this thing. You see, I used everything we have studied up till this point, right? Inheritance, super, this, parameterized constructor, constructors, okay, all those things, right? Okay, cool. So that's the thing. Okay, now let's see how it runs. So let's try to debug it first. Okay, so basically what first thing that happens, let's start from the main. Okay, when this thing is called, then when the first thing, this thing will be executed, right? This gfg, right? O dot object O, this thing calls this gfg, right, with the argument role. So these two things are having same name, right? So there will be a name collision. So to avoid that name collision, we will use this. Okay, now this will roll number will be assigned 10. But what does this super does? This super will call this hello. So if we write here something, you see, if we write this thing here, okay, now I will write hell here. Okay, so now first that hello will be printed, then hell will be printed, and then this, why it's written hello, it should be o dot, one second, o dot row. Okay, cool. So let's see the output, run it quickly. So what should be the output? Hello, hell, 10. Cool, done. This is your next thing. Now the method overloading and method overriding is simpler, right? You just have to keep the same name, and during this overriding, you just have to write the same function, right, with the same name. Okay, cool. So now let's move ahead and talk about the last. So inheritance done, abstraction. Now we'll start abstraction, polymorphism done, and the other thing, that is what we did, encapsulation, right? Classes done. Now the abstract. So basically abstract means if a method does not have its implementation, then it is known as abstract method. So something which is not defined, we didn't define its body, right? It's known as abstract method. Classes can have one or more methods as abstract. So basically in an abstract class, there will be some methods which will be abstract and some which won't be abstract. Okay, cool. So then abstract is the keyword that is used for declaring an abstract class, right? Perfect. So abstract class can have abstract and non-abstract methods done, and it can be initiated because there are some methods which are not abstract, so we can initialize or instantiate, right? We can create objects of this class. Okay, rather it can be abstracted. So what do you mean by the gist of this is that this is abstraction, but it is not 100% abstraction, right? Creating an abstract class doesn't mean we are doing abstraction. Abstraction means hiding unnecessary details. So the details which are not necessary for the user, those will be hidden. So how we will do it? We will do it 100% abstraction with the help of interface. Basically, interface will contain all the methods, right? So all the methods will be there and they all will be abstract. Cool. So how will we do it? So basically this is the interface toy. In that we will have public abstract void start. You see there is no body in it, right? And void run, there is again no body in it. So these two methods are abstract methods, and all the methods, anything inside this class will be abstract. Okay, so anything inside this interface will be abstract, and you don't have to explicitly write public abstract in front of it. Compiler will do this thing, will be done for us. Okay, compiler will do this thing. Okay, cool. So this will be the interface, and any class which is implementing, we have to use the implement keyword to inherit this interface. Okay, cool. So this interface, when inherited, we will use interface. Okay, once we have let me repeat it. I'm going quickly because we are running out of time. So basically what happens if we try to inherit this interface, right? We have to write a keyword implements. Okay, that's it. So if we have done that thing, then we have to explicitly, that is, it doesn't do the thing for us, we have to explicitly do this thing, that we have to write a body, write a function, or implement these functions in our class, in our that class which has implemented this. Okay, multiple inheritance can be done with the help of inheritance. Okay, let me show you. So this is an interface, right? Toy. So both these methods I have written void start and void run. Why I haven't written public abstract? Because compiler will do that thing for us. Now the car is implementing or inheriting this interface, right? We have to write, instead of extends, we have to write implements. What? Toy. So we have to define these methods. These start and run should be explicitly defined in this class. Okay, and we also have to write a public keyword in front of it. Okay, this is very important, else we get an error. Okay, so system.out car started, system.out and sop print sop car running. So then the other class which makes an object of this car, and then we called called start and run on these objects. Cool. So the output will be car started and car running. So this is all about the 4 pillars of OOPS, right? What are they? Abstraction, inheritance, polymorphism, and inheritance. Cool. So this is all about, and we have covered everything in this session, and this should get you started and get your hands dirty, right? And start coding in Java, right? All the things are done, right? I hope you guys have enjoyed this session. We don't have any questions, right? Yeah, I can't see any question. So if you have any questions, right, put them in the comments. I will be glad, I will be more than happy to answer those questions, right? Also do check out that courses that the Great Learning Initiative has started an initiative, the Great Learning Academy, right? In that we have 80 plus courses available for limited amount of time. You guys can check, and if some course suits you, you can just register for that course, and link will be in the description, right? Thank you guys. I hope you enjoyed the session as much as I have. Okay, cool. Thanks.